I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. We are taking up four very important questions which are based on logarithms, change of base. These will help you to perform better in your test. Well, my passion of sharing with you the knowledge of mathematics is basically for you to achieve your goals, for your better grades, and it may help you to carve success path. And if you think you are able to achieve even a little bit of this, I'd like you to contribute and support to help us reach millions globally. Send email to globalmathinstitute@gmail.com to know more and how you can contribute. Here is my request to you all. Let's begin with the questions at hand. So, here are actually six questions. We'll see how do we use the change of base when it comes to logarithms. Question number one is using change of base formula, evaluate log to the base 2 of 9. Now, normally, calculators will have log to the base 10 or e, but not to the base 2. How do we figure this out? So, we use the log change of base formula. Let's say we want to find log to the base a of x, but we need to change the base to b, then it is log to the base b of x over log to the base b of a. So that helps you to change the base and then find the answer. Great. So that is the first question. Second is using change of base formula, evaluate log to the base 27 of 1 over 3. So you need to change the base to get this value, right? Not writing it into exponential form. So that is kind of important to understand. And students who are doing it with exponential form will lose marks in the test. Question number 3 is solve for x and state restrictions. Log to the base 2 of x plus log to the base 4 of x equals to 5. Now, you cannot combine directly using the product rule since the bases are different. Similarly, we have question number 4. So the difference which you see in the second equation is 4 times log to the base x of 5 plus log to the base 5 of x, right? Here you could use reciprocal identity. We'll talk about it. Now question number 5 is solve for x and state restrictions x to the power of log x equals to 100x. Another variation to the equation. So these are the type of questions which you normally see in a test paper and which may sometimes trick you. The last one here is to prove that 3 over log to the base 2x plus 2 over log to the base 6x equals to 1 over log to the base 864x plus 1 over log to the base 3x. So that is a variety of questions which normally are seen in test paper. If you know how to solve them, you are good to get more than 90% marks, right? Let's see one of them, starting with question number 1. So question number 1 is we need to evaluate log to the base 2 of 9. As I said, we could use change of base formula. So we'll change the base to 10. So normally base 10, you don't write 10 here, right? So we just write directly log of 9 over log of 2, right? Now use your calculator. So we have this function here, log of 9 is equal to 0. I'm writing the value 0.954243, right? Divided by log of 2, right? So log of 2, which gives you the answer actually, but I did it directly. So let me just do it again. So we do log of 2, which is 0.301030, right? That is log of 2. So you could do directly saying log of 9, and then you divide by log of 2, right? So log of 2, and what you really get is equal to 3.169925. Normally, we need to, write it in three decimal places. So let me write it as 3.170. So I've written it to three decimal places, rounding off like this. That makes sense, right? Perfect. Let's move on and take up the questions. Question number 2 is using change of base formula, evaluate log to the base 27 of 1 over 3. So we need to find what is log to the base 27 of 1 over 3. Now, you could write 27 as with the base of 3, right? So we could change the base to 3. Then it'd be over 1 of 3 over log to the base 3 of 27. Does make sense to you, right? Now, this is log to the base 3 of 3 to the power of minus 1. And here we have log to the base 3 of 3 cubed, correct? So that gives you minus 1 over 3 as the answer. So we get the solution as minus 1 over 3. Does make sense to you? So we change the base to find the value, right? Great. So I hope this is absolutely clear. Feel free to send an email on globalmathinstitute@gmail.com to learn more. Okay, now here is question number 4. We have the logarithmic equations for you. Question number 4 is solve for x and state restrictions. So let me first state the restrictions here. Since the equation is log to the base 2 of x plus log to the base 4 of x equals to 5, x value should be greater than 0, right? That is the restriction. Now, we could change the base from 4 to 2, and so we can rewrite this as log to the base 2 of x plus log to the base 2 of x divided by log to the base 2 of 4, right, equals to 5. And that gives you log to the base 2 of x plus what is log to the base 2 of 4, which is 2 square, right? So let me take one more step here, okay? So we'll write this as log 2 square, right, equals to 5. So let's move on to the right hand side to solve further. So what we get here is log to the base 2 of x plus, that is 2 square, right? So we get half here to the log to the base 2x equals to 5. Makes sense. So that becomes 1.5 or 1.5, right? And then we can solve it. You can also just combine these. So 1 plus half is 3 by 2, right? So 3 by 2 log to the base 2 of x equals to 5. Correct. So now we could say that log to the base 2 of x is equals to 5 times 2 over 3, right? Which is 10 by 3. And that gives you the value of x as 2 to the power of 10 by 3. You see that? So that is how we'll find, and our answer is x is equals to 2 to the power of 10 by 3. Interesting? So I hope this is absolutely clear. Now let's take up question number 4. Solve for x and state restrictions. 4 log to the base x of 5 equals to 5. Now this is a complex equation. The bases are different, as you can see, right? So we'll have to shift to one base. Another thing which you notice is x5 and 5x. So this is an interesting situation. We could rewrite that as a reciprocal logarithm, right? Let me show you how. So normally we have this formula log to the base, let's say, let me do with this only. So if I use this as x5, right, then I could change the base to 5 itself. So I could write this as log to the base 5 of 5 over log to the base 5 of x. Now 5 of 5 is 1, so it becomes 1 over log to the base 5 of x. Does make sense to you? Correct? So we could write it as a reciprocal. So I'm going to use this property of change of base in solving the question. So let me rewrite. So we have 4 log to the base x of 5 plus log 5 of x equals to 5. So when the base was x of 5, I'm writing it as 4 times 1 over log to the base 5 of x, right? Plus we have log to the base 5 of x equals to 5. Does it make sense to you? So we made it a reciprocal kind of a thing, right? Now we'll multiply by log to the base 5. Okay, so we get 4 plus log to the base 5 of x whole square. Do you see that? Equals to 5 log to the base 5 of x. Perfect. Bringing them all together, we have a quadratic equation now, which is log to the base 5 of x whole square minus 5 log to the base 5 of x plus 4 equals to 0. Right? Now, you could factor this. 4, as you know, is 4 times 1, and therefore, I can now factor this. So let me factor and solve further. So we could write this as log to the base 5 of x minus 4 times log to the base 5 of x minus 1, right? So, uh, so 4 times 1, okay, equals to 0. Now, in this quadratic equation, we have two solutions. One is log to the base 5 of x equals to 4, and the other one is log to the base 5 of x equals to 1. So, we get first solution as x is equal to 5 by 4. Okay? And here we get x is equal to 5 by 1. So these are the two solutions with us, right? So 5 by 4, x to the power of 4, 5 to the power of 4 is 625, right? So we can write this as 625, and here x is equal to 5. So these are the two solutions. They are within the domain, right? So therefore, we can now write x is greater than 0 as the domain, and our solution is x is equal to 5 or 625. Does make sense? Perfect. So that's a very beautiful question. I hope you understand and appreciate it. You can always send an email on globalmathinstitute@gmail.com to learn more and also to contribute, right? Now let's take up question number 5, which is a very important question. Solve for x. Now we are looking into exponential equation, right? And state restrictions. Okay. So we have the equation as x to the power of log x, which is equals to 100x. Now let's take log both sides. So we'll take log of x to the power of log x equals to log of 100x, correct? Apply the property, power rule will give us log x times log x, right? Equals to, here we have log 100 plus log x, correct? Okay. So this basically is log x whole square. You see that? And log 100 is basically 2, right? So that is 2, right? So plus log x. So again, we'll end up into a quadratic equation, right? And now we can solve it just as we did the last one. So let me rewrite this as log x whole square minus log x minus 2 equals to 0. So minus 2 means I could do minus 2 times 1, right? So I could write this as factored form log x minus 2, right? And plus 1. So log x plus 1 equals to 0. So that gives us two solutions, log x equals to 2, and the other one is log x equals to minus 1. So from the first one, we get x equals to 10 to the power of 2. From the second one, x equals to 10 to the power of minus 1. So x is either 100 or x is equal to 1 over 10. You see? So we get two solutions here. Both are within the domain, right, where we want x to be greater than 0. So both are the solutions. I hope you understand, right? So now let's move on to the last question. So we have to prove that 3 over log to the base 2x plus 2 over log to the base 6x equals to 1 over log to the base 864x. Well, there is a typing error here. So this should be minus, okay? Not plus. So sorry for this correction. This has to be minus. So let me rewrite this question. You need to prove that 3 over log to the base 2x plus 2 over log to the base 6x is equal to 1 over log to the base 864x minus 1 over log to the base 3x. Okay, so that is the correction. Perfect. Now you're also going to use the reciprocal log relation, which is log to the base bx can be written as 1 over log to the base x of b, right? We showed it earlier, one of our solutions, right? I hope you remember. We have done this earlier, right? Okay, great. So let's rewrite. So we get what? We get 3 times log to the base x2, right? Plus 2 times log to the base x of 6 equals to log to the base x of 864 minus log to the base x of 3, right? Now you can write this as log to the base x of 2 plus log to the base x of 6 square equals 2. Here we'll apply the rule, which is 864 divided by 3, right? Quotient. Now in the left hand side, we can write the product, which is log to the base x of 8 times 36, right? 6 square equals to log to the base 864 divided by 3. Let's divide. So 3 goes 2 times, right? 3, 6, 26, 3 times 8, right? 20, 288, log of 280. On the left side, if you multiply, what do you get? You again get 288, right? And on the right side also, we have 288, correct? So we know left hand side equals to right hand side. Perfect. So that is how we are going to answer this particular question. So I hope that makes a lot of sense to you. So we have solved all the questions, right? Note here there was a correction, right? This was negative. And if you really think that my videos are making some difference in your life, I like you to contribute generously. Perfect. You can always send an email on this particular address to know more. Thanks a lot and all the best.